Alright guys, today we are looking at our final set of notes for the entire semester. So we are nearing the end at this point. We are looking at solving radical equations today. So to start off, let's just review how we square something. So our method of squaring, when we have x minus 5, when we square that, we really mean x minus 5 times x minus 5. So you can FOIL that out. X times x is x squared minus 5x plus 25. And then combine that, or you can use what I call square double square. So I square the first, double, multiply, and then double. So I have minus 5x if I multiply those together. And then I'm going to double it, so I get minus 10x and plus 25. Whatever method works for you to do that, use it, and that's fine. Go ahead and try to do these on your own, and then unpause the video and see if you got them. I'm going to write out what I have up here. So square the first, double the middle, and square the second. Square the first, double the middle, and square the second. And then this last one, I'm going to square the first, and then I'm going to go ahead and multiply this out for those of you following along with me, so you can see what's happening here. I'm going to write it out. So if I'm looking at the outside terms, I'm minus 3 radical x plus 2, and then a minus 3 radical x plus 2 again, and then plus x plus 2, because I squared that. So then I have 9 plus 2 gives me 11. I have minus 6 radical x plus 2, and then I have plus x. All right, so to solve, first, isolate the radical or the power. So we've been solving things like this before. We want to get the radical, we want to get it by itself. We're going to raise both sides to the reciprocal power. Then we're going to simplify. We need to check our solutions. Solutions that do not check are called extraneous. Those are solutions that don't work. They don't give us the correct answer when we go to check them. So to solve, just like we've been solving before, we want to get that 4th root of x by itself before we do anything to it. So to start, I'm going to subtract 5 from both sides. So I get negative 4th root of x equals negative 5. I'm then going to divide by negative 1. Probably a more direct route would have been to move the 4th root of x over, but that's okay. So 4th root of x equals 5. Now, the inverse, the opposite of the 4th root, is raising it to the 4th power. So I'm taking it to the 4th power here. So 5 to the 4th then is 625. So x equals 625. Now, before I box that in and say, yes, this is the answer, what I want to do is go plug this back in. 5 minus the 4th root of 625 is equal to 0. The 4th root of 625 is 5, so 5 minus 5 equals 0. 0 equals 0. Yes, that works. So this is an answer. It's not an extraneous solution. All right, let's try another. So we have 3x to the 4/3 power equals 243. First thing I'm going to do is divide by 3. Let's get this x to the 4/3 by itself. So I get x to the 4/3 is equal to, and 243 divided by 3 is 81. Now, if I want to get rid of the x to the 4/3 power, I want to multiply to get x to be 1. So power to a power is what we multiply. So if I flip that fraction over and I multiply by 3/4, 4 times 3 is 12, 3 times 4 is 12, I now have x to the 12 over 12, which is x to the first. So I'm going to multiply this side by 3/4 as well. So I have x equals, and I have the 4th root of 81 to the 3rd power. So the 4th root of 81 is 3 to the 3rd power then, so x equals 27. Now we need to check this. So we're going to plug in for our check 3 times 27 to the 4/3 is equal to 243. So 27 to the 4/3 is 81. 3 times 81 is 243. Yep, that works. So x equals 27 is a solution. All right. First thing we want to do here is get that square root by itself. So I'm going to add 4 to both sides. So the square root of 2x plus 8 is equal to 10. Now the opposite of a square root is squaring. So I'm squaring both sides. So 2x plus 8 is equal to 100. Subtract 8. So 2x equals 92. Divide by 2. X equals 46. All right, don't box it in yet. Let's check it. So the square root of 2 times 46 plus 8 minus 4, does that equal 6? So 2 times 46 plus 8, that's 100. Minus 4 equals 6. Square root of 100 is 10 minus 4 equals 6. 6 equals 6. That one works as well. So this is an answer. And I want to point out, I didn't put plus or minus 10. We didn't put that square root in there. It was already there, so we assume the positive there. All right, on this next one, we are looking at a radical on one side and then x plus 2 on the other side. So I'm going to go ahead then, since that radical is isolated, and I'm just going to square both sides. So I'm going to use my square double squared method here. So x squared plus 4x plus 4 is equal to 2x plus 28. Now I'm going to move everything to one side because I want to factor this. So I'm going to subtract 28 here at the same time. So I get x squared plus 2x minus 24 is equal to 0. Something that multiplies to negative 24 and adds to positive 2. 6 and 4 come to mind. So I need x plus 6, x minus 4. So x equals negative 6, x equals 4. We have 2 of them to check here. So I'm going to check negative 6 plus 2 is equal to the square root of 2 times negative 6 plus 28. So negative 6 plus 2 is negative 4 is equal to negative 12 plus 28. So negative 4 is equal to 16. The square root of 16, negative 4 is equal to 4. Oh, that one doesn't work. Let's try the next one. So I have 4 plus 2 is equal to the square root of 2 times 4 plus 28. So I have 4 plus 2, I could have simplified that already, is the square root of 8 plus 28. So 6 is equal to the square root of 36. 6 equals 6. That one does work. So 4 worked, but it did not work for negative 6, so this is extraneous. All right, let's try another. Here's another one of these where we have to square both sides to get rid of that cube root, or that square root. So I have x squared minus 6x plus 9 is equal to 4x. So I'm going to subtract 4x from both sides so that I can try to factor this. So x squared minus 10x plus 9 is equal to 0. So I need two numbers that multiply to 9 and add to negative 10. Well, negative 9 and negative 1 should work. So x equals 9 and x equals 1. I'm going to plug these in. So to check, I have 9 minus 3 is equal to the square root of 4 times 9. So I have 6 is equal to the square root of 36. 6 equals 6. That one works. And then I have 1 minus 3 is equal to the square root of 4 times 1. So 1 minus 3 is negative 2 is equal to the square root of 4. Negative 2 is equal to 2. That one does not work. So it doesn't equal 1. That's extraneous. But 9 did work. All right, this next one, we have a 3/2 power equals to negative 6. I want you to think through this. What does that halves power mean? It means we're taking the square root. When can we take the square root and get a negative value? And the answer is that's never going to happen. So here is a no solution problem. So watch out for those problems. All right, equations with two radicals. So when you have equations with two radicals, I'm going to move that one radical over to the other side. I'm going to add 3 radical 2x to the other side so that I can start to work with both of these sides by squaring them and getting rid of that radical. So then when I square here and square here, then I end up with 4x plus 28 is equal to 3 squared is 9 times 2x. So I end up with 4x plus 28 is equal to 18x. So I'm going to move the 4x over. So I get 28 is equal to 14x. Divide by 14 on both sides. So 2 is equal to x. Now before we say that that's okay, let's do our check. So the square root of 4 times 2 plus 28 minus 3 square root of 2 times 2 should equal 0. So we have 8 plus 28 minus 3 times the square root of 4. So I have the square root of 36 minus 3 times 2. So I have 6 minus 6. So 0 equals 0. That works. So x equals 2. All right, let's try a couple more of these. So For example 8, we're going to do exactly the same thing. If you felt confident in what you just did on the previous problem, I would try this one on your own because we're going to solve just like we did before. So I'm going to move that 2 radical x to the other side. And then I'm going to square both sides. So I get 12 minus 2x, and I get 4 times x. So I'm going to add 2x. So 12 equals 6x. Divide by 6. So 2 equals x. Well, let's double check that. So the square root of 12 minus 2 times 2 minus 2 times the square root of 2 is equal to 0. So 12 minus 4 is equal to, or minus 2 radical 2 is equal to 0. 12 minus 4 is 8. So the square root of 8 is the square root of 4, square root of 2. So that's 2 radical 2 minus 2 radical 2 is equal to 0. So 0 equals 0. That one works. Box it in. All right. Now this one, we're going to do very much the same way. We have radicals on both sides. We're going to square both sides. So the square root of x plus 5 squared is just x plus 5. This 5 squared is 25. If I double this, I get minus 10 radical x. And then I have plus x when I square that. I'm going to subtract x. So then I have 5 equals 25 minus 10 radical x. Then I'm going to subtract 25. So I get negative 20 equals negative 10 radical x. And divide by negative 10. So I get 2 equals the square root of x. To undo, since we've now isolated that radical, I'm going to square it, and I'm going to square this side. So 4 equals x. And then we need to check it. So the square root of 4 plus 5 should equal 5 minus the square root of 4. So the square root of 9 is equal to 5 minus 2. Square root of 9 is 3. 5 minus 2 is 3. That one works. So 4 equals x is an answer there. All right, last example of the whole semester. So what I'm going to do is move one of those radicals over. I think the easiest radical to move would be the one that is subtracted. So if I add radical x minus 1 to the other side, I get the square root of x plus 3 is equal to 1 plus the square root of x minus 1. So I'm going to square both sides here. So x plus 3 is left here, and then I have 1 squared. Then I have double, so 2 radical x minus 1. Again, if you're more comfortable foiling, do that. And then x minus 1, the square root squared is just x minus 1. So I'm going to subtract my x's from both sides. What I want you to notice is these 1's cancel. The x's then cancel, so I get 3 equals 2 square root of x minus 1. So then I'm going to divide by 2. So 3 halves is equal to the square root of x minus 1. Now that the square root is isolated, then I can square it. So 3 squared is 9 over 2 squared is 4. And I'm left with x minus 1. So add 1 to both sides. So add 4 over 4 to both sides. And I get 13 over 4 is equal to x. Before we box it in, we need to do a check. So I'm going to do a check down here. I get the square root of 13 over 4 plus 3 minus the square root of 13 over 4 minus 1 is equal to 1. Well, 3 we could write as 12 over 4. So 13 over 4 plus 12 over 4 is 25 over 4. Oh, that's a minus. Then 13 over 4 minus 1, minus 4 over 4. That's 9 over 4. 13 minus 4 is 9. We want to check that that's equal to 1. So the square root of 25 is 5. Square root of 4 is 2. Square root of 9 is 3. Square root of 4 is 2 is equal to 1. So 5 over 2 minus 3 over 2. So 5 minus 3 is 2 over 2. So 1 equals 1. That one checks. So 13 over 4, while not our prettiest answer, is our answer for that last example. All right, guys, that's all I have for you. If you have questions on solving, you want more practice, come in and see me. Otherwise, I'll see you in class.